Hello, this is Greg Allison with Galactic Gregs, coming to you from an undisclosed location somewhere in the Milky Way galaxy. Many of you have heard about phosphine gas on Venus, and many of you have heard that this phosphine is a sign of life. But there's some questions about this. Of course, you can ask, well, is it really a gas that came from life, or did it come from some chemical process? But there's a better question. If there is life on Venus, how did it get there? How would life possibly have gotten on Venus? So that's what we're going to talk about. We're going to talk a little bit about the phosphine discovery, and we're going to talk about some of the natures of potential life in the clouds of Venus, and we're going to talk about how could it get there. And then I'm going to talk a little bit about a subsequent follow-up video I'm going to do on colonizing Venus and why Venus is probably the best single spot to go to colonize in our solar system right now if you're looking at a planetary body. Non-free orbiting body, as I tend to favor with the rotational O'Neillian type space facilities. Venus may be easier to do than even that. So let's get into it. I'm going to do a share. We're going to go to my little PowerPoint presentation here. You know, us engineers are very much in love with PowerPoint, right? There we go. Life on Venus. How? How now, brown cow? Well, there we go. The phosphine gas. So, which was discovered, and it's interesting that what we find is that phosphine was discovered by this James Clerk Maxwell telescope. While they were looking for how to baseline what you would expect to find in other planets of phosphine, like on Jupiter and Saturn and brown dwarfs, where it's actually found. So they were trying to develop a baseline for this, and they actually discovered it on Venus. And the discovery of it was not expected, especially in the amounts they found it in. So it's also found higher in the atmosphere than they would have expected. So it's raising a lot of questions about how it got there. It just so happens that phosphine is actually a toxic gas. But on Earth, it only comes from biological processes. We can manufacture it. I mean, naturally, it does not come from geological or chemical processes on Earth, and it does occur on like Venus and on brown dwarfs, Saturn, and Jupiter, just because it's believed to have started down really deep in the planet where the pressures are so high and maybe get brought to the surface on some occasion. But the pressures on Venus aren't really that high, especially for the amounts that they're finding it there. So this leaves a lot of enigmas about what they're finding and how. But indeed, see, Jupiter is one of those places where we're finding the phosphine, but the signature was found on Mars, Venus. So how did that happen? Could it be, you know, that there's some chemical process still here? Just because we're finding it doesn't mean necessarily it is just life. But there's some other markers that indicate life and had people already suspicious about life in the clouds of Venus. And oh, by the way, as you might know, the phosphine is really just phosphorus and hydrogen atoms here forming a neat little acid, right? So as we come down in here, this is, you know, the depiction of it. It just so happens that the Venus atmosphere has another anomaly, that there's some unusual light absorbers up in this atmosphere. And people are going, what is that? And some people are already starting to theorize, oh, maybe it's life. So that's really strange. Actually, Carl Sagan, you know, billions and billions of Carl Sagans, was the first to theorize that there might be life in the atmosphere of Venus. Of course, he also theorized there might be life in the atmosphere of Jupiter. I remember an article he once wrote called Star Tar in a Tartar Jar, where he was thinking, you know, the analogs of some of the stuff they were finding in the lab tartar jars could lead to life in an atmosphere like you'd find on Venus, now you might sinkers and floaters. And he was writing this stuff back in the late 70s, early 80s time frame, back when I first started subscribing to Astronomy magazine. I found it very fascinating. Of course, that's Carl Sagan for you. So, again, Saturn, where we are also finding things of interest there. And so here's the paper. This paper is one where they're talking about the phosphine gas in the cloud decks of Venus. And they really tried to knock this out. They tried to say, well, let's find what other processes it could have been that might have generated it. And they looked at Venetian volcanism. They looked at other atmospheric phenomenology, lightning discharges, and they wound up shooting them all down. They just couldn't come up with why you should have that phosphine there. So that was a really odd thing. And it just so happens that, they tried real hard. They just couldn't find another thing that might cause the phosphine. Well, it just so happens that also there's other stuff in the Venetian atmosphere that indicates that you might have life there. For example, you find that there's more carbon monoxide than you should have. Or exactly, no, this other way around. There should be more carbon monoxide. But yet, the carbon monoxide should be getting generated by UV and lightning and things like that from the carbon dioxide, but they're not finding the amount of carbon monoxide they would expect. It's as if it's being consumed. And again, I mentioned, there's those light absorbers they're seeming to find oddly in the cloud tops of Venus. And so they're also finding hydrogen sulfide and sulfur dioxide in quantities that exceed what they would expect. I mean, these are chemicals that combine with each other. For them to be existent in the quantities that are existent, they must be getting replenished, and that can be done by biological processes. So that makes for a lot of strange oddities. And also, as you know, the Venetian atmosphere is full of sulfuric acid. And, we think, oh, acid's a terrible thing. But, what can survive in an acid environment? Well, actually, in Yellowstone, we find that there's bacterial mats. That's what this orange color is, bacterial mats that are living in the high acidic environment of these hot springs at Yellowstone National Park. So these are called extremophiles, bacteria that can survive in extreme environments of high acidity, radiation, temperature, the various extremes that we find where we would expect normal life can survive. There are some organisms that always just thrive in these environments. And it turns out that acid, sulfuric acid, might actually be a fuel, a food to them. So, and what's also found is these phosphine gas is found at an altitude in the atmosphere, which is, in miles, about 31 to 50, and it's also in kilometers, you can see up to 60 kilometers. There's a little temperate zone in the upper atmosphere of Venus. And in fact, in this temperate zone, temperatures would have like liquid water. It's like on Earth, and the pressures are like on Earth. So the temperatures and pressures are like on Earth. But it's got more acid, although the acid is higher concentrated toward the ground. Of course, there's still sulfuric acid up there. So that generates a lot of questions as to, is this a viable area? This is a cloud deck area where they're seeing the absorbers. This is a cloud deck area where they're seeing the phosphine. And the pressures are far too low to create phosphine there. So how are you getting phosphine? Even the pressures down here on the surface are not quite high enough to generate this phosphine gas. So maybe it's possible that there's some other process doing this. And it's also possible that there are other processes explain away the light absorbers and the low in density of carbon monoxide and the higher hydrogen sulfide and sulfur dioxide. So there may be some other phenomenologies that explain that away. But it's starting to be a whole lot of different things coming into context, right? And plus we're seeing there's kind of a habitable zone right here, a Goldilocks zone in the atmosphere of Venus. So they've kind of tried to describe this as a cycle in which bacteria could be cycled up in spores, get up here where there's water and grow, and they think it might get heavy and sink back down where it's too hot and turn into spores and just basically circulate. So that's kind of the phenomenology they're thinking might. That's just some people trying to come up with plausible scenarios. This doesn't mean this is the mechanism that takes place, but this is a potential viable mechanism to explain how microbes could survive and cycle through the upper atmosphere of Venus. So it becomes interesting to think about. This could be real. This is a habitable zone on Venus, the planet closest to the sun. Of course, on the surface of Venus, it's a pure Hades. I mean, look at the surface of Venus today. The surface of Venus is an awful place. The surface temperature is hot enough to have rivers of molten lead. Or to put it in a way that some of you guys are familiar with since you use soldering irons, it's twice as hot as the tip of a soldering iron. And you know, that's darn hot. That is mighty darn hot. So I try to put it in terms that, you know, everyday folks could understand. Of course, I've melted lead because I have, you know, smoke poles that I have liked to play with in my days. So twice as hot. And the surface pressure is 92 times that on Earth. So if you drop down the surface of Venus, you'll be burnt up by acid, burnt up by the heat, and crushed to bits. The Russians managed to get a Venera 13 lander on the surface of Venus, and it actually managed to operate there for a couple of hours, sending pictures back. And these are pictures from the surface of Venus. And I had the great pleasure to have went to Moscow in 2010 and met with Rock Cosmos and also the spinoff company called Inky. And Inky is a company that developed the probes that the Soviet Union and later Russia was to send out into space. And it included this lander. So I actually got to meet and spend a good bit of time with one of the guys who worked intimately on this lander. And he was a great guy. I really enjoyed talking with him. But this is what we believe Venus used to look like. I mean, you go, how would anything possibly survive on Venus? How could anything be there? How could life have came from there? Well, bam. This is what we believe Venus looked like once upon a time. In fact, according to Michael Way and Anthony Del Genio of the NASA Goddard Institute of Space Studies, they've done studies confirming that liquid water once existed on Venus. And from their analysis and studies, they believe that Venus had liquid water on its surface from a period of 4.2 billion years to 715 million years ago. So through most of the history of Venus, it may have been inhabitable. It might have been a plush planet, just like we had once assumed it would be. And we once thought Venus was just this planet. It was just so hot and steamy. It had all these clouds, and underneath there were dinosaurs and tropical plants. But no, we found it to be a pure hole, right? So pure Hades, a hot spot. So what happened? So life may have started on the surface of Venus. This is one possibility for how it got there. Just one. Life may have started on the surface of Venus. Imagine that. In fact, life on Earth may have started on the surface of Venus. This is even Mars. This is what we call Panspermia. Because Venus was closer to the sun, it was probably favorable for life to form earlier. Earth got hit by another protoplanet, so if Earth had life starting on it, it probably got a big upset and reset, and it took a little bit longer for Earth to cool down. It's interesting that Earth rocks, as soon as they got cool enough to be solid, you find evidence of life. That don't even make sense. We'll go into that in just a second. But think about that. Life finds a way. How is that how it survives? How does life survive from that to that? Well, how would it get in the atmosphere? Of course, there's this little adage, life finds a way. So just maybe it got into the upper atmosphere and came back into this. It could have evolved. So we know if life started on Venus, it either adapted or it died out. And if it died out, maybe it got reseeded. That's a possibility too. But, you know, we have life on the upper atmosphere of Earth. So there's a good chance that it would evolve or may have been reseeded or both. Where did life on Venus originate in? If there was life on Venus back in this day, in which Venus was much more posh, it's possible that it didn't even originate there. We'll talk a little bit about Panspermia and some of the prospects for Panspermia. Like I said, life finds a way, right? I remember Jurassic Part 1. Of course, there were those that long thought, well, in space, there are all kinds of chemicals. We see this, we see molecules, we see the beginnings of life. The amino acids have been discovered in free space, in the clouds, the nebula space. In time, a lot of these molecules form, a lot of the building blocks for life. But we haven't actually detected life itself in these nebulas. But maybe that's a good incubator, a good place for some of this stuff to get started. And Of course, we've heard quite often of panspermia. This is a chart from a presentation by Richard Hoover to the Huntsville, Alabama L5 Society. And this is recorded on one of my earlier videos on my channel. So if you go to my channel and click the videos tab and scroll down, you will find this video in there where it's Richard Hoover. Richard Hoover, like Dr. Fred Hull, are early advocates for the concept of panspermia. Now, Richard Hoover is one who studies meteorites, and he's got a lot of interesting photographs of meteorites, not just Allen Hill's meteorite, but several that looks like you can find algae bloom specimens of. Now, hey, I'm saying looks like, I'm gonna tell you what, if you see his photos, and then when he compares what he's finding in meteorites and what is in nature, it's pretty astounding. Those are in that presentation. I encourage you to look at it and make up your own mind. I'm not making any claims here. I'm just saying make up your own mind. I'm not even claiming there's ever been life anywhere other than Earth, but the prospects are interesting. You know, I've seen it suggested that if the entire planet of Earth were a big ball of water that was perfect in every square centimeter for the formation of life, or the proper folding of the proteins it would take to construct life, that it takes so long to get the first protein folded right that if you built a bridge across the entire length of the universe, the entire width of the universe, and you put an amoeba on it, and it moved at the speed that the amoeba moves, the time it would take for that protein to form in a sphere of water on Earth to fold just right so it could be a precursor to the building blocks of life, the DNA, that it can move the entire universe back and forth across that bridge, one atom at a time. One atom at a time, like 80 times before you'd have the probability of getting one protein folded right. That's pretty astounding. That is very astounding. So the chances of life just to being instantly evolving on the rocks on Earth as soon as it got hot seems interesting. The fact that they might have had life on Venus and Mars, well, did all this start somewhere else? And did it get there that way? Now, like I said, life might have originated on Venus. And then through the panspermic concept where you have an impactor, hits, and ejects stuff into space, or bacteria just floats up. You know, hey, our International Space Station is coated with living organisms that is picked up in orbit around the Earth. Think about that. That thing's traveling 17,500 miles an hour around Earth. And the atoms come up from the atmosphere are not traveling that fast, so it's really smacking them. Yet they're viable microorganisms on the International Space Station. It's also believed that within meteorites that if an asteroid hits Earth, that some of the chunks that get blown off are big enough that the temperature at the core of them would not drop sufficiently, or would not heat up sufficiently to cook everything therein. And if you look down in we believe now that there's more biomass in the rock of Earth than there is on the surface of it. There's living organisms all through the rock, way down deep. And some of those are extremophiles that already adjusted to high pressures and temperatures. So the idea of them getting blasted by something big and knocked off the Earth. Of course, when something hits Earth and blasts, it also knocks the atmosphere off. You will find in the studies of many astronomers, they talk like Dr. Lewis from Arizona talks about a planet over time is losing atmosphere from continual impacts. It's a comet and asteroid erosion of the atmosphere of a planet, John Lewis. So this is a prospect, and I think that maybe that's why we had bigger insects back in the ancient days. It's not because the oxygen content in the atmosphere was higher, but maybe because the pressure was. I'll let the biologists solve that one, but that's just my proposition. Not even a good theory as yet. It's just something I'll throw out there as a hypothesis. So maybe that's why we had bigger animals in the past, you know, like dinosaurs with nostrils that were only the size of a horse could support a big animal. And maybe that's how the larger animals survived and didn't get their blood vessels breaking out at the bottom due to the difference in atmospheric pressure from their head to their ankle. Maybe the atmospheric pressure was just higher. Okay, enough said on that. But it's quite possible that, you know, some of our atmosphere gets knocked off, and also chunks of rock get knocked out. Maybe water gets splattered out by the same token. I mean, you see the big depictions of an impact and what gets thrown out. It's possible that life could survive that. And we have found now that life is very resilient, especially diatoms, tardigrade, and even multicellular organisms like the what do you call it, the tardigrade, that little bear thing. which we believe is now on the moon from some of our landers and a few other things. Those are real tough. But then it's interesting. You will find the guy who discovered DNA, one of the two guys that discovered DNA, Dr. Crick, believed real strong in directed panspermia. It was just improbable of all this stuff to take place. He said that the prospects of having DNA evolve in a short period of time in the history of Earth, from the tidal pools and lightning and volcanoes and a primordial soup forming the complexities in a DNA strand. He said that would be like expecting a tornado to go through a junkyard and assemble a perfectly functioning 747. Now think about it. DNA is a very complex functional molecule that self-replicates within a cell. Cells are very complex devices. In fact, the inside of a cell, all the machinery in it is like New York City in complexity. We think of a cell as some little thing, but when you really study the complexity of what goes on inside of a cell is enormous. So how did life get started? How did it get to any of our planets? Well, Crick believed it was directed, as in a higher intelligence were involved. A greater creator, whoever you want to assume the greater creator is, that is what he believed. And he certainly had a lot of credentials. He was a discoverer of DNA. And you can see he had credentials quite, just look him up. So panspermia, this idea that this stuff may have came to Earth or Venus, it could be Venus, well, not Earth. That's the way Earth looks today. Might have been the way Venus looked once upon a time. Maybe even Mars. That life may have come in on rocks, along with oxygen and water and other things like that. We may have got our oceans from meteorite impacts, water-bearing meteorites. Oh, didn't want to go there yet. So this is what we're talking about. Panspermia may be the answer, but could it have been that life came to Venus from panspermia from Earth or another nearby planet? It takes the Earth 250 million years to cycle with the sun around the entire galaxy. So during that period of a quarter of a billion years, life from any planet on Earth, in our galaxy, life from any planet or body originating in our galaxy could infect the entire galaxy. So maybe we're kin to everybody in the galaxy in some way. Should they be out there? At least from a cellular standpoint. It's a possibility, or there could be competing biologies out there. But it may be that we're all related. It may have all started at one time or one source, maybe directed by the greater creator, maybe sparked. The universe may be hardwired to have life. There's a whole lot of things, a lot of rabbit holes we can go down here. What we do know is we do have life. What we do know is we're seeing signs of what may be life in the atmosphere of Venus. There's prospects that there was life on Mars at one time. We're going to find out a lot more in the next few years. It's going to be very interesting. I would submit that we really need to go to Venus to explore Venus and find out what we can to see what there is there to find out. The prospects are just so awesome that it's mind-boggling. Now, Greg, how do you go to Venus? We can't go there. You just told us the atmosphere would crush us, burn us, and acidify us. Well, there's that habitable zone, right? And I just kind of gave it away a second ago. So NASA's proposed this program called HAVOC for altitude Venus orbiter, whatever. So HAVOC is, and other programs of balloons, high altitude balloons that would float around Venus. And in that level of the atmosphere where the temperature is like on Earth, the pressures are like on Earth, but if you have the gas bag inside the balloon, heat it up just a little bit as it could be, because this is a greenhouse. And by the way, there's twice the amount of sun at Venus as there is the Earth, so that may not be so hard to do if you got a plastic structure up there. It'd be hard not to have an intense greenhouse. I know I've got a greenhouse, an aquaponics greenhouse back here behind me. And in the summertime, it's going to, if I didn't have the fans going in there and have some kind of cooling system, it would get to 120 degrees when it's 80 or 90 outside. Yeah, it gets hot fast, and that's just with 1 layer of plastic. So, yeah, you can get a lot of buoyancy. I'm going to do another video on specifically on colonizing Venus, and I'm going to go into great detail on some of my calculations and findings for just what you could do with high altitude structures on Venus. Now, here is the concept for dirigible airships. As you might know, I've actually launched rockets from balloons. I've got a lot of experience flying balloons, and I've also delved a little bit into some concepts for developing airships. So these are things that really interest me, and I've done some calculations, and I find the capabilities of what you can do with these structures on Venus to be totally outstanding, especially if you adopt Buckminster Fuller's tensegrity sphere or geodesic dome type structures. Now, he believed in tensegrity sphere, which is a structure which everything is in tension. There's no elements in compression. These are all cubes, but they have wires pull through them in such a way that everything is tension. There's no compression in the structure he's holding in his hand. Now, Buckminster Fuller, as you might know, was the guy who invented the geodesic dome and many other things. He termed the phrase spaceship Earth. And the Fullerene buckyball or Fullerene, Buckminster Fullerene, as you might call it, was named after him. Because carbon C60 happens to range in such a way that it looks like a little geodesic sphere. Isn't that amazing? Mother Nature loves the principles that he found. And by the way, he said we didn't invent anything. We only discovered what Mother Nature already had. And indeed, the buckyball seems to have put that out there. So he had this concept for Cloud 9 stations, big tensegrity spheres to float in the upper atmosphere, maybe on Earth. But see, it might be better to do this even on Venus. The cool thing about Venus, even not being so hot, is that when you get down that depth of the atmosphere, there's enough atmosphere that it actually blocks the radiation that would be coming from the sun. It's actually safe for human habitation. The temperatures, the pressures are right. The one thing you've got to account for, though, is the level of sulfuric acid. It's not as bad as down deep, but you would have to engineer for that. But then again, that's an engineering problem. That's what us engineers are for. And so I'll be talking about that in my next video. So expect me to talk about floating around on Venus and buckyballs, Buckminster Fullerenes. Well, no, not buckyballs, not carbon C60. Well, that will probably come in handy in some ways, but maybe tensegrity spheres or domes. I mean, what I find is the buoyancy, he was talking about facilities a mile across. If you build a facility a mile across, just a few degrees difference in temperature will give you so much buoyancy, you will lift more than you can put in it. That's what I have found in my calculations. So, my friends, the cool thing is life finds a way. And maybe this could be Venus again one day. Some people say we should terraform Venus and get it back to that. Of course, Venus' rotation rate is slower than a year for one rotation. The cool thing is at the cloud tops, at the equator, the speed of the clouds is about 2¼ days, or to temperate zones, closer to a day. So you can really make Venus a place to colonize in that atmosphere. I will show you some concepts for it, and we'll say, well, why in the world would we want to terraform? Let's just build into the upper atmosphere. I'll go more into that in a follow-up video on this. So just bear with me, and we'll go there. We will have some fun with it. But before I do that, I'm probably going to do a video on space station or space stations, because there's been some interesting developments there. And so I'm probably going to talk about that. So I've been remiss for a while. I'm not done any videos on this channel. So bear with me. I've got more coming. Please subscribe to my channel. Bang the update notification bell. I hope to be putting a few more videos out and pick up the pace some. I still got taxes to do and some other things I'm way behind on. And I do have another channel I put a lot of videos out on called Green Gregs. And that's an urban homesteading, prepping type channel in which I talk about things going on in the world and development of life support systems, essentially. Worm farming, organic garden, aquaponics, greenhouses, growing microgreens. I covered all that stuff. Not so much of the aquaponics yet, but I'll do more of that in the future. So, but you can support my channel, this channel, by subscribing, banging the update notification bell, and I'll put the links below from Green Gregs if you're interested in long-term food storage and seeds. I would encourage everybody to grow their own gardens, the things going on in the world today. are rather shocking. And hey, it's a good way to learn life support to get ready. I really hope that this is the future we've got where we can go out and do things like this. But we do have a lot of challenges in front of us today. So, my friends, I'm going to say thank you for watching. I hope y'all have an awesome week here, and we shall see you later. Thank you.